Hello everyone, welcome to SIG Autoscaling meeting for Monday 27th of January 2025. We currently have a couple of items already on the agenda. If there's anything anyone else wants to add to the agenda, please go ahead and do that. I'll drop a link in the notes. Cool, but Philip and Paul, do you want to kick us off?
Philip, you want to go first?
Yeah, up to you can go ahead, or I can introduce the topic and we can switch. Yeah, so I had this topic a while back here in SIG Autoscaling. It's like previously the CAP was called Evacuation API. We have renamed it to Eviction Request API, and there has been a couple of changes there. So the CAP is in a mostly complete state. So, and why do we want to talk about this is, so basically we try to solve like major issues today in Kubernetes, basically regarding like node drain and basically eviction in general. So like any descheduling use case. So even you have a node drain, for example, due to maintenance or node autoscaling, or a descheduler wants to move some of the workloads, or some applications wants to migrate some workload somewhere. So it's just a general descheduling topic, I would say. And here also comes autoscaling. So when we ask to today, when we ask to evict an application from a node, that like there is no chance, like for example, the horizontal pod autoscaler or any other autoscaling logic to inject that in like itself and basically offer better like graceful behavior. So today you have either one option is use a PDB, which pod disruption budget, which either like during the node drain, either you have a capacity in the PDB and you will get your pods evicted like straight immediately, or the PDB will block the eviction and basically no eviction will happen until there is a capacity in the PDB. So like in one case, the problem is that the cluster admin basically has like a node drain blocked and like cannot proceed until the application is healthy again or in like a drainable state, or we lose some availability. An application basically needs to first downscale its replicas before it can upscale again. So maybe later, like some controller can kick in and bring the replicas up. So like we would like to have like a better behavior. So basically to allow autoscaling up first. So let's say you have a drain and for example, the horizontal pod autoscaler could kick in and first it would upscale like the reasonable amount of replicas that is needed for the drain to complete. And once these replicas are gone, once they are running, then we could make the other replicas go, like the draining replicas go away. So like the eviction request API basically offers this functionality. Like today eviction is basically imperative. So we basically expect that at the end of the eviction request, either the application or the pod will be killed or like deleted, or we will get a block, like the request will complete unsuccessfully. So this API basically offers a declarative way of doing things. So we can declare on each pod like how many, like set of interceptors, for example, to offer a better like migration behavior. Like it can be application specific or like some broader behaviors like the HPA. And each interceptor has a priority. So during like node drain, we would first create these declarative eviction requests, and basically we could cooperate between different components to either like before we actually start the pod deletion, we can cooperate and offer better behavior. So like this is one approach, and one other approach which Paul is suggesting, which is a bit simpler, but yeah, well, I will let him talk about the second approach.
Yeah. So another approach would be to take and put on the pod a condition saying, hey, there's an eviction blocked here. That gets you signal, but it's less powerful in other ways. And particularly for auto scaling, you need a PDB to kind of follow that. So you may need something like a PDB that is also auto scaled with deployment, which seems doable, but it's another thing that you kind of need to do. Or you'd need to go and use Prometheus metrics or something like that to combine your metrics and say, only look at pods that don't have this eviction blocked to try and get me what I want. And so we're kind of going back and forth on these. I'm curious on the autoscale SIG's thoughts. Do you want to be involved as like an interceptor maybe in the future to say, oh, we know requests are coming in? Or would you want to push people towards looking at conditions and writing their own metrics and autoscaling PDBs? If this is something that you guys have thought about, are there some issues that we could go poke at? Because we're still kind of coming at what do we want to do here, if that makes sense.
Okay, so we are definitely, I am at least from the Cast Autoscaler perspective, interested in anything related to drain and making eviction better. We've had issues with the eviction behavior and how simple it is for a long time. I think Carpenter would be interested as well. I think we do evict things slightly differently, but we want to converge on like one mechanism. I think we've been talking about it for like 2 years now, or a year at least, like that we would like to have one mechanism of, maybe it's sort of on a different level than the pod, but we would like to have one mechanism to drain a node. Like like right now we have probably like 3 or 4 different like core Kubernetes components that drain nodes or evict pods from them, and every one of them does it slightly differently. So aligning this behavior would be nice in itself, and like the details of how the new API looks would probably help Cast Autoscaler. So I'm definitely interested in reviewing the cap. What you've talked about, that like I have some questions to the details, but I prefer to read everything first, and we can continue on the cap.
Sorry, just one question on the, I joined a bit late, so apologies if that was already answered, but I saw that this is, this cap is split out from the declarative node maintenance one. Did you talk about why it was split and why do we want something not node level, and or are we going for a separate API for pods?
Yes. So I think we have discussed also this like part of the declarative node maintenance cap, but I think in general, like the scope is much bigger for the node maintenance, and I think we can offer like a useful functionality sooner. And as you have mentioned, like the cluster autoscale, it would be exactly the good example, like good first use case for that. So basically, this would allow like to offer, like as you said, like we have like a set of node draining behaviors today. Like for example, one is kubectl drain and one is the autoscaler, and we could basically drop in the eviction request as a replacement. So we could offer this functionality sooner, and like later once we converge on the node maintenance, it could use that as well, but it's not like it's separate at the moment.
So are they like
Sorry.
incompatible, or are like, is one supposed to build off of the other?
I mean, basically, the node maintenance would be to basically give a better signal to like all the users on the cluster, to admins, SREs, and like to actually see what's happening, like to have a concept in general in Cube to see what's noticed under null maintenance. As today there are many such concepts, and it's not easy for people to get hang for them. And this would basically allow that to actually have a stable API, but the implementation for the better eviction and basically add like nicer behaviors would be part of the eviction request cap. So, I think we will struggle a bit to like push the node maintenance further. Like, yeah, we have plans to do that, but I think the eviction request is much more attainable at the moment. Yeah, if I can go back to Paul, like as he mentioned, his feature is based on PDBs, or like sort of that it detects if the PDB is blocked or not, like if the eviction can proceed. So I think that like it could solve some use cases, but I think for cases like the autoscaler, it would not work for applications that, for example, are not guarded by PDBs. So, or I mean, even for the HPA, I see problems like you would need to manually update the PDB, like how the application scales. So that might be also a bit have an issue.
I have one more quick question, because you're mentioning like detecting whenever a PDB would block eviction. So CA sort of already does that. Have you looked at how this works in practice, and like, is this the behavior you want to achieve? Is this something you want to make work better? Because right now CA won't try to scale a node down if it has a pod that doesn't allow for any disruptions in its PDB. The issue is that if even one disruption is allowed, CA will proceed, and then the pods will have to be drained one by one by the current eviction API. So that takes a long time if there is termination grace period in play, and then we run into issues. So I'm just wondering if you've looked at this behavior and how it relates to what you want to achieve.
My first time hearing about it, so I'm interested in taking a look.
Yeah, I thought so, because it is like an implementation detail. So like, it pops up in our support cases whenever people run into this, but it's probably not something that's widely known.
But I think this is mostly a question of scoping. So I'm really interested in your guys' opinion on the eviction request kept. I don't really have a fundamental problem with the new API. I'm just kind of wondering how long it would take to get people to converge on it. If everybody converges on it, then that's great. So if you guys read that and are like, this is something that we're interested in doing, then I think we kind of move forward with that. If you're like, this has got problems and we think it's going to get hard to get convergence on, then we might go with this condition to satisfy 50, 60% of the use cases while we continue working on that. So that's mostly what we want here, I think.
Yeah, that makes sense. One thing I would like to avoid is us working hard to sort of make one thing work, and then if the maintenance cap would be incompatible with that would work. So I just want to make sure that that doesn't happen, but that should also be pretty quick. And scoping level, I agree.
Yeah, just to reiterate, like the node maintenance can proceed with that or without that. So they are I split them like for the moment, for the time being. Yeah, I think like the major problem today is like that we have like there's like some set of issues that are like across different like SIGs and scopes. So, and they are very hard to solve. So for example, now we have an issue in the replica set controller that like people want to have a nicer behavior, like when the replica set downscales. They would like to like preserve the scheduling constraints. So like today when you downscale, you can there can be one node which is biased and they can take up most of the replicas. And this is very hard to achieve to get some consensus, like how should actually the deletion of the pod and how all the applications should be affected. So I would imagine that like in the future, like this is like an extendable API. So you can actually have multiple like components and you have priorities and you can actually hand control over between each component. So I know like like today in Kubernetes, there is no built-in like nice descheduling behavior, like a descheduler, but you could, for example, inject a descheduler into this like decision point. So like you could actually say which replicas should be preferably downscaled, and then the replica set would look at these eviction requests and then would just downscale it itself. Like we would really not like to, for example, have this like expensive logic for this like scheduling logic embedded in the replica set. So we would like to have a signal from above.
Yeah, this is a very good idea. Like pods getting out of the scheduling constraint ideal state during scale down is probably one of our like biggest, like you can't really achieve high availability and like spreading the pods either via pod topology spread or via pod anti-affinities. Really, none of the primitives that Kubernetes has, none of them are like handle scale downs and the randomness of them today. So I think what you're describing would be an idea to solve it, and I'm really interested in learning the details.
Yeah, I actually have an example for this in the cap. Like there is like for the scheduling component, it does not have the full details, but it's basically doable. So yeah, if you could please give us feedback on the cap, that would be great. Thank you.
Awesome. Thanks very much for that.
So like currently we've been talking a lot about like how cluster autoscaler relates to this, right? I'm wondering like in terms of how VPA currently uses eviction, if you have spent some thoughts on that as well already. Because like my understanding is that one of the advantages or one of the use cases for that the eviction request API would be that, for example, for a stateful set, you would be able to like decide the order of pods in which they are evicted, for example, in an interceptor, right? And like VPA looks at new request recommendations and then tries, like currently it uses the eviction API to like go through all of the pods and just call evict on them, right? And then either PDB allows for it or not. And then in the next iteration, it has like 1 minute loops. It gets back to this and will do the same thing again. Yeah, just call evict on it. And if PDB admits, then that's fine. And if not, then nothing happens. And then the next loop comes in and so on and so on. So I'm wondering like how that currently, I mean, it's pretty much built around that imperative part of that logic, right? And I'm wondering like if we have huge changes in VPA coming to support this, or like if this would like just work. Yeah, I haven't read the cap, like just trying to get an idea about this. But yeah, I'm wondering like if you already spent some thoughts on this.
Yeah, so yeah, sorry, I have not looked at the VPA use case much. So I mean like the basic premise like behind the cap is that like by default all the things would stay the same. So if you do not have like any interceptor like the fallback of the eviction request is basically the normal eviction. So you would always fall back to the eviction, and if we want like nicer behaviors, they have to be implemented. So, for example, we have an option to implement just a better behavior in the deployment controller. So when we have like the max search field, we can use this to actually search the replicas. But if the deployment does not have the search fields, then it will just fall back to the eviction, like the same like with the HPA. So I don't know if I don't know how it will all fall together with the vertical pod autoscaler, but yeah, it's customizable. That's what I want to say.
For the pod condition proposal, you need something else to do surging for you. And that's doable. I've got like a toy project that'll actually watch PDDs and say, hey, are you allowed disruption 0? And are some of these conditions coming in? Go and surge this going according to max surge. But I think one of the questions I have with Autoscaler is how taboo is it to have other things changing replicas when, especially HPA, kind of considers it owns that. Because if it's okay, it's a normal thing, then you can have two controllers trying to kind of get you out of the block state. I think that'd be fine for VPA. For HPA, now you have two people changing replicas at the same time, two pieces of code changing at the same time. That might lead you to sadness. So I wasn't sure what guidance was there.
Do you have any HPA experts on the call that would be willing to read the cap?
I'll give it a review. I think.
No, I mean the thing Paul was talking about is the condition issue. That's not part of the cap. Like we do not like mention the changing the replicas there.
Is that that's the separate issue you've
yeah exactly
been liked? Okay, cool. Yeah, I'll have a look at that as well. Awesome. Thanks. Cool. Any more on that? Ishmael.
Yeah. Last week, Foreman, who is a colleague of mine, opened one issue related to the VPA. Long story short, in our environments, we don't use Prometheus as storage backend for VPA. We use the Kubernetes backend, which is using vertical pod outscaler checkpoints. And Foreman in the last weeks and months was investigating one issue where the VPA recommender could actually scale down in unexpected manner the resource recommendations to the min allowed values. I think today he couldn't join and asked me whether I can ask in this round whether someone from the VPA maintainers had time to look into the issue and maybe provide some feedback or vote or share opinion on the ideas for fix listed in the issue.
I guess Ray or Marco, either of you like a bit of bandwidth to give that a review.
Yeah, I mean, I do have an opinion on this. I was also participating in the investigations and like how to implement this, right? But I'm interested in other people's opinions, right? There's basically two ways to tackle this. Like one way is after reading from a checkpoint, dropping some data, and the other option is ensure that you don't write data that after reading from a checkpoint again, like is under some threshold. So both ways work or should work, and we can also just settle for like our choice of implementation, do a PR, and then go with that. That's also fine. I guess we just want to avoid doing double work. If people's opinion is like you should be doing it the other way, or maybe there's a third way. I don't know.
Mhm.
That's not it.
I can try look at it this week. I've been avoiding it because it looks quite long and complicated. But I mean, if you have a fix, I can probably just figure out the problem and support one of the ideas that you put forward.
Yeah, sorry folks, I lost track of this one last week, so let me take a look and see what I think as well. But I also agree with Adrian. If we feel like we have a good path, I'm also happy with that.
Okay.
Thank you.
Cool.
Thanks.
Thanks.
And I guess 1 minute left, but hopefully just to be a quick one. Jean-Marc.
Oh, it's just an FYI. I started one VPA 1.3.0 release helping Ray.
Awesome. Thanks very much. Cool. And we're at time. Thanks very much, everyone.
Thank you.
Next week.
Bye.